So we are going to be discussing on cleansing condensation. And the topic for us is what? Cleansing condensation. Cleansing condensation is a reaction of what? Esters. That is the reaction of what? Ester. So when we talked previously on adult condensation and the cross-adult condensation, they are reactions dealing with what? With aldehyde and our what? Our ketone group. But cleansing deals with what? Esters. So what do we know as esters? Our ester is it's the functional group known as RCOO what? This is what? Our esters. So now cleansing is a reaction of what? Is a involving esters that have what? Alpha hydrogen. That is cleansing condensation is what? A reaction of what? Esters that have what? Alpha hydrogen, that must be present in basic solution to condense into what? Beta keto esters. That is to condense into what? A beta keto what? Esters. It is a reaction of what? Esters having what? Alpha hydrogen, which is one of what? The most prominent and important parts. So now in under our classic condensation, our normal base, that is the most common base we use is what? Sodium ethoxide. We can see one of the most common base, the most common reagent. One of the most common reagents is what? Our sodium what? Ethoxide. So when this undergo cleavage, we end up having Na what? When sodium ethoxide undergo cleavage, we end up having what? Na plus and what? OET what? Minus. You can see our sodium ethoxide, we are going to have Na plus and OET minus. And this is the one that attacks the alpha what? Hydrogen. It is the part that what? That attacks what? Alpha hydrogen. So let's give a quick example. That is our ethyl acetate, otherwise known as what? Ethyl ethanoate, undergoing cleansing what? Condensation. Undergoing cleansing condensation in the presence of sodium ethoxide, to leading us to the formation of ethyl acetate. Leading to the formation of what? Our ethyl acetate, giving us what? A beta keto ester. Let's calculate. You can see this is our ketone group. So this is our what? Our ketone what? Group. You can see the alpha carbon and the beta. You can see the beta esters. You can see it. A beta keto what? Esters. You can see. You can definitely locate it. You can see our alpha carbon. You can see this is our alpha carbon. This is our ketone group. That is a our ketone group, that is a beta keto what? Esters. So now the next thing is what? Is to go for the mechanism. That is how do we arrive at this? That is showing the mechanism on the step-by-step process on arriving at what? At this. So that the mechanism. So we can see that the first thing we need to know that under cleansing condensation, we only make use of just one single reactant. That the same goes to our adult condensation, where we also make use of just one single reactant. That at some point we later introduce the same reactant. That is, we make use of it twice. So under cross cleansing, where we also make use of two reactants. So but we can see in this case, the single reactant, there is a presence of what? Of alpha hydrogen. That is, we can easily what? Deprotonate. But under the cross cleansing, one will have what? An alpha hydrogen, while the other would have an alpha hydrogen. So let's go. Let's introduce our base. That is our OET minus. That was emphasized earlier. So now this attacks the alpha hydrogen, leading to this. You can see you successfully form what? An enolate. You form our enolate. So the next thing is what? Is to bring same reactant into the equation. You bring back same reactant. You can see you need to what? Bring back what? Same reactant. So this attacks. This attacks the carbonyl part, leading to what? The localization of what? Pi electrons. So which will eventually have this O minus and OET. So you can see we eventually what? Have this. So the next step is what? Is to link this part and this part together to form our carbon-carbon bond formation ring. So that is link this part and what and this part what together form a carbon what bond formation what ring. So to link both of them together you have this. You can see we have this. So to link both of them together, so we've successfully what link both together. But in the case of cleansing what condensation, we have to form beta. We have to form beta keto what ester. That is, we have to form beta keto esters. Unlike the adult condensation, when we are forming beta hydroxy ketone. But this we have to form a keto ester. So in this case, we don't need to hydrolyze. So we don't need to what hydrolyze and what at this point, that is the pi bond that was delocalized at this place, we will return it back, and returning that pi bond back, that is the excess electron back to form a double bond, there will be an elimination of what of this group. So there will be an elimination of what of this group, returning it what back to the equations. So now, so that is to form a what a ketone group. To return this back, we have CH3C double bond what O. So we want to, so our main reaction is just to return this. So to return this back, leading to the formation of double bond. So the moment that this bond enters into this part, we form a double bond, and there will be elimination of this hydroxide. We can see we have what an elimination of this particular what group. So let's have it. We have CH3C double bond O. We can see we stabilize this. Then the hydroxide is eliminated. We have CH2C double bond OET plus our what hydroxide. We can see we successfully give this is our this is the mechanism of this Claisen condensation. That is the first step. We are preparing what just one reactant. The first step is to deprotonate the alpha carbon. So we want to deprotonate, we follow our enolate. So we bring back the reactant, we attach the carbonyl compound, leading to the localization of the pi bond, giving us O minus. You can see it. So the next thing is to form a keto esters. So that the next thing is we link both of them together, leading to the formation of this. So now the next one is that in this case of Claisen condensation, we don't hydrolyze to form hydroxy group. We the pi bond that has been delocalized, we bring in resonance effect, so that we can see the pi bond that was being delocalized, bringing it back to the reaction. So the moment the pi bond enters, there will be elimination of this group. So there's an elimination of this group. So we can see in our product. We can see in our product. We can see in our product. We have a ketone part, and the hydroxide part has been eliminated in the equations. So this is a successful Claisen condensation reaction. This is a successful Claisen condensation. So now the next example before under Claisen condensation is the Claisen condensation of ethyl propanoate. You can see this is an ester. So you have it before us. That is the condensation of the Claisen condensation of propanoate. You can see with our base, our sodium hydroxide. So now the first step, that is to locate the alpha hydrogen. This is our alpha hydrogen. So we successfully locate our alpha hydrogen. So we bring in our base OET our hydroxide minus. We can see we bring it in, it attacks the so we can bring, let's just break this structure down. So we can have it as CH3 CH2 C bond OET. We can see, so this one will definitely attack our alpha hydrogen, leading to the formation of this. So leading to the formation of what? Of this. So you can see we only make use of one reactant. So at this point we've already formed our isolate. So we can introduce the same reactant into the equation. So we introduce same reactant into the equation. So then the anion attacks the carbonyl group, leading to the formation of this. So which causes the localization of what? Pi bond. You can see there have been the localization of pi bond. We have what? O minus. The next one is what? Is to form our carbon bond formation what? Formation ring, to form a more big, a more complex what? Compound. So the next one is what? Is to link both equation what? Together. You need to what? Link both equation together. So you have this. You can see successfully what? Link both what? Together. The next one is that resonance. In this case, we don't idealize. As for the condensation, the aldol and the cluster, we don't idealize. So there's a resonance effect being played in this part. That is, the excess electron will form a double bond. That is a ketone group. We have to form a ketone what? Group. So the excess electrons move back into this to form what? A double bond. So the moment we have a double bond in, so this group what? Will be eliminated. That is, this OET minus what? Will be eliminated from our product. So which lead us to having this. So you can see this is our product. You can see our product. This is a T2 T3 also what? Pentanoate. You can see our product. So this is a successful Claisen what? Condensation of ethyl propyl what? Norate. This is our simple mechanism. So we are talking about the Claisen condensation. We are dealing with what? Just one reactant. The first step is what? Is to locate our alpha hydrogen. Then bring in our base, that is to protonate the alpha what? Hydrogen. You can see there have been a reduction of the hydrogen. We have two hydrogen here, so we just have a single hydrogen here. So that is to show that there have been what? A reduction in hydrogen. There have been a deprotonation. You can see our anion will form a what? Endolate. So this is successfully endolate being formed. So next will be we introduce the same reactant. So to what? Delocalize the what? Pi bond, leading to what? O minus. So the next one is what? Is to link both of the reactants together. So we can see there's a successful what? Linkage in both what? Reactants. So the next one is what? We have to form a ketone group. So the way we can just simply form a ketone group by resonance effect, the negative so comes back, then turns to a double bond. So the way there's a double bond formation, there will be elimination of what? Of this hydroxide part. See, that is the OET minus what? Is being eliminated along what? The process. So leading to what? A formation of what? Of a ketone group. So we successfully formed a beta ketone what? Ester. We successfully formed what? A beta ketone ester. So our next discussion is on what? On cross what? Claisen condensation. As our usual saying, that is cross Claisen condensation, we deal with what? Two reactants, makes up what? Of two reactants. One with what? An alpha hydrogen and the other without what? An alpha hydrogen. We still make use of same reagent, our sodium hydroxide in the process. So now we are going to consider some few examples, like the cross Claisen condensation of what? Of ethyl benzoate. Makes up what? Ethyl what? Benzoate and ethyl acetate. You can see the first example. We have two examples before us. We have our ethyl benzoate and our ethyl acetate. So the two examples, that is to undergo cross Claisen condensation. One, there is the presence of alpha hydrogen, while in the other case there is no the presence of what? Alpha hydrogen, similar to the likes of the cross aldol condensation, where we have two reactants, one with alpha hydrogen and the other with what? without alpha hydrogen. That is, the first step is to what? Locate between the two reactants which one possesses what? An alpha hydrogen, and which one what? Does not possesses alpha hydrogen. So we can just start from here, from our ethyl acetate. So that is the presence of alpha hydrogen here. So now that is, we need to what? Deprotonate. So the first step is what? Is to deprotonate. We locate the one with alpha hydrogen and what? Deprotonate to form our what? Our enolate. So we have CH3, C. So introduce our hydroxide. So this one attacks our alpha group, so forming our enolate. So since we successfully what? Form what? Our enolate, we can introduce this one without the alpha hydrogen. We can introduce it in, so we can see we bring it in. We introduce it to our equation. So this enolate, the anion attacks the carbonyl group, causing the localization of what? Pi what? Bond. So we form this. So the next one is what? Is to form a carbon-carbon formation. We link both of them together. You need to link both of them together. So that you link both of them together. So link both of them together. So our usual step is that we need to form a double bond. As this is a ketone, we need to form a ketone group. So the excess electron comes in to form a double bond, and there's elimination of what? Of this what? Group, our hydroxide group. So leading to giving us this product. So giving us what? This product. So this is a successful cross-Claisen condensation reaction mechanism. So we have our example 2 under cross-Claisen what? Condensation. So we have our ethyl formate and our ethyl propanoate undergoing cross-Claisen what? Condensation. You can figure out that on one group there is a presence of what? Alpha hydrogen, while on the other group we don't have what? Alpha hydrogen. So we, through proper analysis, we can figure out that we can have it under our ethyl propanoate. So now we need to form our what? We need to deprotonate. So we can from our ethyl propanoate. So attacking our alpha hydrogen. So we are left with this. So we successfully form what? Our enolate. So we can make use of what? The second reactant at this point. So this our anion would attack our carbonyl group, so causing the localization of what? Of pi bond, so leading to the formation of this. So the next step is what? Is to link both reactants together, to link this and this what? Together. So to link both reactants together to form a carbon-carbon formation reaction. So we have this through proper linkage. So we start from this our anion part. So the next one is resonance effect. So this single bond, the excess electron comes in to form a what? A double bond, and there's an elimination of what? Of this group, leading to the formation of this. you have this. So this is successful cross-Claisen condensation reaction what mechanism. So now this is, I think, so this is the end of our class. Please like and subscribe and follow our channel.